Hi, welcome to the notes for 3-11. Today we are going to look at solving logarithmic equations. First, let's recall the domain of a logarithmic function. If we have something in the form y equals log base b of x, where b is greater than 0 but not 1, our parent graphs end up looking something like this. We would have a vertical asymptote on the y-axis. We know it goes to that point 1, 0, and would have a point at b comma 1. So most of our functions would end up looking something like this, where it'll run right along that asymptote, it'll curl out and go out this direction, right? And it will continue to go down the other way. All right, so if it asks what the domain of our logarithmic function is, right, we're just talking about the x values. So it looks like it starts, really close to 0 and goes out to the right forever. So our domain for our logarithmic function should be x is greater than 0. Or if we wanted to write it in interval notation, we would say 0 with a parenthesis, comma, infinity. Either one of those would be correct. Now, when we think about that, if our domain is just positive numbers, right? Everything greater than 0 is just all positive numbers. That means that our value up here for x can only be a positive number. Okay, so we tend to call that the value, log base b of that value x. X must be a positive number. So that makes sense though, right? Because if we took our base b and we raised it to the power of y, b is only going to be positive numbers. So if you take a positive number and you multiply it or divide it by itself over and over again, right, it's still going to be a positive answer. So we will never have a negative value right here. That is important to know. So as we go in here to look at solving equations, you'll see it says give the solution as an exact value and then as a decimal approximation. Be sure to check for extraneous solutions. Remember, extraneous solutions are solutions you get when you solve it algebraically, but it doesn't work when you put it back into the equation. So, does not work when plugged back into the equation. And remember, that is our extraneous solutions. All right, looking at the first problem, it says log base 3 of x equals negative 2. What we're focusing on right now is we have one log statement on one side of our equation. So we have one log on one side. So how do we solve that? Well, we're just going to take it and we're going to rewrite it in exponential form. So thinking about it, a lot of times with our exponentials, we rewrite them in log form. Now we're going to rewrite this log in exponential form. So when we do this, we have our base is 3. We're going to raise it to the power of negative 2, and it should equal x. We have 3 to the negative second power equals x. And we know 3 to the negative second power is 1/9. So x equals 1/9. And that's totally fine. If we put 1/9 in there, it does make sense. It does work out. Now let's look at the second one. It's another very similar statement. We have one log on one side, but now our x is down in the base. So let's take it here and let's rewrite it into exponential form. We've got x to the negative second power equals 3. Let's rewrite our x to the negative second power as 1 over x squared is equal to 3 over 1. We'll cross multiply to get 3x squared equals 1. Divide each side by 3. And right now we're looking at x squared is equal to 1/3. Our goal now would be to take the square root of each side. We're going to get the absolute value of x is going to equal the square root of 1/3. So x should equal positive or negative square root of 1/3. And we're just going to leave the fraction under the radical right now. It's not super important to have a rationalized denominator there. So when we see this here, that means that x could be a positive square root of 1/3 and x could be a negative square root of 1/3. But let's think about it for a moment. If we said log base square root of 1/3 equals -2, okay, that could make sense. Okay, oops, I forgot the 3, sorry. Now it should make sense. But I can't write log base negative square root of 1/3, right? Because we said the base always has to be a positive number. So this one right here is not going to work. We can't do that. Okay, so in this case then, that means that x cannot be a negative. So we're going to say here, x is just positive square root of 1/3. That would be our answer. All right, let's move on. Now we've got another equation. This one is also 1 log on one side of the equation. Okay, so we're going to solve it the same way. We're going to take it and we're going to rewrite it in exponential form. We're going to say 2 to the 3rd power should equal x squared minus 1. All right, well, 2 to the 3rd is actually going to be 8. So if 8 equals x squared minus 1, we can solve this by getting our constant terms together. So 9 is equal to x squared. Take our square root of each side. We'll say the absolute value of x equals 3. So x is going to equal positive or negative 3. And now we need to check to see if this one works. Okay, so if I put my 3 in there, it would say log base 2 of 3 squared minus 1 equals 3. Well, 3 squared is 9, minus 1 is 8. We can totally have an 8 in there for our value. So this one does make sense. 3 is going to work. And then if we take it and we put our negative 3 in, I know that we were saying that there can't be any negatives, but let's look and see what happens. If I put my negative 3 in here and I square it and then subtract 1, that's going to be 9 minus 1 is 8. You see we have the exact same equation written there. Okay, so since this value ends up being positive, we're good to go. So if I put a negative in here, but it simplifies, this whole expression simplifies to give me a positive, we can put that negative in there. So our answers are x equals both positive and negative 3. Next one, we have log base 4 of x plus log base 4 of the quantity x minus 3 equals 1. So now we're looking at 2 logs on the same side. So let's use our properties to combine as 1 log. So since we're adding here, we know that we can rewrite this as log base 4 of x times the quantity of x minus 3 equals 1. And now we can take it and go around the world and say that 4 to the 1st power is going to equal x times the quantity of x minus 3. So if we're trying to solve that, let's go ahead and distribute that x through to get x squared minus 3x equals 4. We'll set it equal to 0 by subtracting 4 from each side. And now we can look to factor this, right? So I'm going to recopy it up here. That should factor into x minus 4 and x plus 1. So when we set them equal to 0, x equals 4 or x equals negative 1. Now let's check them. Okay, if I take this negative 1 that's right here and I put it in right there, or I put it in right there, you're going to see that I would have the log base 4 of negative 1. plus log base 4 of negative 4 equals 1. Those can't work. We cannot have a negative value in here, so we got to throw these out, throwing out that answer. And then when we plug in our 4, we have log base 4 of 4 plus log base 4 of 4 minus 3 equals 1. And this just makes way more sense. We know that this equals 1. We have log base 4 of 1 equals 1. Well, we know that log base 4 of 1 has to equal 0. And then 1 plus 0 is 1. So we know that this one is correct. So our answer for this problem is just x equals 4. Next one, we have log base 7 of x equals log base 7 of 2. Well, for something like this is like when we have an exponential equation that has the same base on each side. Right now we have the same log base on each side. So we have 1 log on each side of the equation. Now, if they have the same base like they do here, then we're just trying to figure out what value of x we need to put here so that this side equals this side. That's pretty easy. We can drop the logs and just say that x equals 2. All right, the next one says log base 2 of x equals 2 times log base 2 of 3 plus log base 2 of 5. So we're going to need to first start out by looking at this right side, right? We need to use the previous properties there. We're going to combine those into one statement. So the first thing I would do is, put my exponent back up here. So this is really like saying log base 2 of 9 plus log base 2 of 5. And since we're adding 2 logs with the same base, this will be log base 2 of 9 times 5, or 45. And right now you see that equals log base 2 of x. Well, in order for this to be true, this x value has to end up being 45. So we're going to say x equals 45. Now let's think about, can we check it here? Right, if I plug in 45 up here, there shouldn't be any issues because it's a positive number there. Moving on. Now we have log base 7 of x minus log base 7 of the quantity x minus 5 equals log base 7 of 6. This is very similar to the previous one. Let's take it here and rewrite this part as just one single log statement. So we have log base 7 of x over x minus 5 equals log base 7 of 6. And now since we have one log on each side, that's all that's going on, we can drop the logs and say x over x minus 5 is equal to 6. And now we'll just cross multiply to solve it here. So x times 1 is x, and that should equal 6x minus 30. Subtract our 6x, we have negative 5x equals negative 30, so we know that x is going to equal 6. Now let's check it. If we put it in up here for this x and we put it in for this x, it should still make these statements true. We have log base 7 of 6. That works. And then we have log base 7 of 6 minus 5, which would be 1. And that should work as well. So our answer for this one, x equals 6. All right, last one. Log base 2 of x minus log base 3 of 9 equals log base 2 of x plus 1, the quantity of x plus 1. So first thing here, now we've got multiple logs on the side, but they have different bases. Well, let's just take a quick look at this one. Log base 3 of 9, I think, actually has a value. We could say that that's the same thing as 2. So we have log base 2 of x minus 2 is equal to log base 2 of the quantity x plus 1. And now we need to make a decision. How should we try to attempt this? Well, Because we have logs on both sides, but we also have this term that's not a log, maybe I want to make it into a log. This would be the same thing as log base 2 of x minus 2 times 1, I think is the way we did it in class the other day. And how can we turn 2 into a log base 2? Well, we know it's going to be log base 2 of x minus log base 2 of 2. And actually, I forgot to put my 2 in the front there. So there we go. So we have minus 2 times log base 2 of 2. Because remember, this part of it right here is just a value of 1. That's our 1 there. So this 2 is right here. And then now we can take it here. You can move this 2 up here. Say log base 2 of x minus log base 2 of 2 squared, which is 4. And now you can rewrite this as 1 log base 2 of x over 4. Right, that still equals log base 2 of x plus 1. And now all we need to do is we have the same log base on each side. We just need to set these values equal to each other. So x over 4 is equal to x plus 1. Let's cross multiply to get x equals 4x plus 4. Subtract, we've got negative 3x equals 4. So x is going to equal negative 4/3. Now let's just check it. Because if I put that in up here and say log base 2 of negative 4/3, that's not going to work. Okay, so since it doesn't work in that one, we don't even have to plug it in the other ones. For this one, there would actually end up being no solutions. But you have to take the time to check and see as you're going through it. All right, that's all I got for you right now. If you have questions, please make sure you reach out and ask. Thanks for watching.